Hello everyone, this video is about transformations past paper. Number 1, express 2x squared minus 12x plus 11 in the form of this. So 2x squared minus 12x plus 11 is equal to a times x plus b all squared plus c. We expand x plus b all squared, we get this. We multiply everything by a and we get this. So for the coefficient of x squared, on the left we have 2, on the right we have a must be 2. For the coefficient of x minus 12 on the left, 2ab on the right, but we know the a is 2, so 2 times 2 is 4, and we have the b. And for the constant term on the left, minus 11, on the right, ab squared plus c, so 11 must be equal to ab squared plus c. We know the a, we know the b, we can find the c. Number 2, the function f of x is defined as state the largest value of the constant k for which f is a 1-1 function. So from part 1, this is in the vertex form, and from this vertex form we can find the vertex easily, which is 3 minus 7. So 3 minus 7 is the vertex form. We know this is the vertex. We know the vertex from this vertex form function. So the domain is x is smaller than k. So for x is a 1-1, the largest value is k is equal to 3 because we are using the left side, and when the k equals 3, this is a 1-1 function. For this value of k, find the inverse and the domain. So this is the original function, and we know that the k is the answer to the previous part, which is 3. And now what we do is we use the completed square form from part 1. We replace with y, and then we swap the x and the y, and then we are solving for y. You can switch sides, and we add 7 to both sides, divide both sides by 2, take the square root both sides, we have plus minus square root, and add 3 to both sides. We have this form here, or actually when we move this, we have plus 3. But to check whether we have to use plus or minus, we can just use any random number in the domain. The domain is x is smaller than 3, so we can use, for example, 0. If we plug in 0, we replace this x with 0, or use this form, replace this x with 0, we get 11. So f of 0 equals 11, which means f inverse of 11 must be 0. So now we replace this x with 11. 11 plus 7 is 16. 16 divided by 2 is 18. 18 divided by 2 is 9. The square root of 9 is 3. So because it has to be 0, we have to use the minus, because that is the only way we can get 0. If we use plus, we will get plus 6, which is not 0 here. So we have to use minus, and we have the inverse. This is the inverse. We have to use f inverse of x. And for the domain and the range, we have the domain of the original. If you want to find the range of the original, you can just look at the vertex form again. As you can see in the vertex, the range of this quadratic is y must be bigger than minus 7. We know the range of the quadratic. If we know the range of the quadratic, all we gotta do is copy this, put it here, copy this, put it here. If you want to find domain, this is all you need. This is the range of the inverse, the domain of the inverse. Last part, with k now taking the value of 1, so the k is now 1, and we have g of x now. Find the largest value of the constant p, which allows the composite function f g to be formed. Okay, so we are using composite functions. We have the f, we have f, and we have g. We have this domain of f, and we have the domain of g is p, and we want to find the p. So f g of x means we plug in g into the f, the range of G must be in the domain of F. So what is the range of G? Let's find the range of G. Well, we know that the domain of G is X is smaller than P. So if X is smaller than P, then the G must be smaller than P plus 3. So since this range must be in the domain of this, which is smaller than 1, we know that this P plus 3 is supposed to be equal to 1. So the P is supposed to be equal to minus 2. So the largest value of P, so that we have the composite function, the P must be minus 2. And to find the inverse, the composite function, we can just plug in G into F. Well, the G is x plus 3, so we plug in x plus 3, we replace this x and this x with x plus 3, and then we simplify, expand the quadratic, and we do the expansion, and simplify, we get the composite function. It is similar. Okay, the graph of y equals f of x is transformed by the graph to the graph of f of 2x minus 3. So we have inside times 2 and outside minus 3. Inside means horizontal and times means stretch. So horizontal stretch, for horizontal the factor is 1 over 2, and for outside that's vertical plus or minus translation. So we have vertical translation, minus means you go down. So in conclusion, you can say it's the horizontal stretch followed by a vertical translation, or in the opposite order, the stretch first and then the translation. They are both correct. State the coordinates of the corresponding point on the original curve. Okay, so we know that we have 5, 6 on the transformed curve. The translation is horizontal stretch and translation. This is the final result after the translation. So before the translation it's gotta be 5,9, because the translation is minus 3 here. 9 minus 3 is 6. So this is before the translation. Now before the stretch is a horizontal stretch, and horizontal stretch means it is affecting the x value. So the x value is initially 5 here, but this is after we squeeze it. So before squeezing it's actually 10. So the original point is actually 10. So from 10, after the horizontal stretch factor 1 over 2, we get 5,9. Now we have this, and after we translate this 3 units down, it's going down here, we get 5, 6. So it checks. In the diagram, the original graph solid and the broken is a transformation. Describe the transformation to give the combining. Okay, so the transformation is, you see, we have the original graph, or you can use this point from the x-axis to, now it's here, so from the x-axis 3 times, so 2 times 3 is 6, 3 times taller. So if it's 3 times taller, of course we have a vertical stretch in the y direction, and we are moving this whole graph. After we stretch, we move it 4 units to the right. So translation for 0. In part B, state in terms of y of x the equation. Okay, so this is the original, and from the original we stretch factor 3 in y direction, so in vertical direction 3 on the outside, and the translation is for 0 we replace the x with x minus 4, because 4 means you go to the right. Go to the right means minus 4 in the function.